So, for instance, that blank screen is okay. I've now filled it with these lines of code, which are enabling me to, number one is I'm able to visualize an image, natural color composite image, Sentinel-2 for Lusaka, Zambia. Okay. And from that, I'm also able to create a force color composite, color infrared for the same. And this map, this image is for September 2024. And then I'm also able to calculate a normalized difference vegetation index for the same area. And so that's what this line of code is going to do. This script is going to do. So this is what we're going to go through. Let me just do this. So I'll just post in the chat. I'll post in the chat the link to the script. Okay. Now you can access. So somebody was asking how to get the script. So here is the script. I've just shared the code in the chat. You can click on that link and then you'll be able to open the script. So you see that, so I'll wait for people to, just for a few minutes, I'll wait for people to open the script. You have all these lines and these lines with forward slashes. And if you just click on run and you see that nothing is happening, you click on run, nothing is happening. You click on the run button, and nothing is happening. Okay. So by default, the map centers to USA. For me, it's in Lusaka here just because I had searched for, I had already the script and ran the script and then I got here. Okay. But for you, it shouldn't, it should center to USA. But we'll see how we can center it to our study. Now, the first thing when we are working in Earth Engine, I think we can start with a brief introduction to JavaScript programming. So the JavaScript programming that you need to know, for you to be able to work with Earth Engine is not that advanced. You don't need to be a software engineer for you to work with Earth Engine, because the number of methods or functions, methods available, objects available in Earth Engine already developed for you. All you just need to do is to put them in your code, and then you get the stuff done. But you just need to have an understanding, a basic understanding of JavaScript programming. Okay, so if you don't have background in computer science, you don't need to be scared at the mentioning of programming, computer programming. You just need a few basic things, and then you'll be able to work with Earth Engine. So that's what we're going to start with. So the first thing that I'll mention is what are known as comments. So a comment in programming, in computer programming, is like, okay, you're writing something and you don't want that stuff to to be part of the processing, or you would want to describe what you're doing. So a comment is used for you to describe what you're doing when you are writing a computer program. You are writing a computer program. Why? There are some times when you do something, you write something, and it takes maybe a year for you to go back to the same script that you had developed. So a script here is just a collection of lines of code, okay, of programs or statements that you write. So if it takes a year before you go back to the same script, you would want to remember what you did and that a year ago for you to be able to reuse the same code and be able to interpret what you're doing. So you add comments for you to be able to easily remember stuff. So in Earth Engine, or in JavaScript, you can add a comment by writing double slashes. So double slash. So for instance, what I've done here, everything in this code as it is commented. So everything is a comment. But we will uncomment these lines or these statements for us to be able to process. So whatsoever is written as a comment is not interpreted or executed, okay, so it is not going to be executed. It's just skipped as a comment, just like it's just a comment. But to take out the one comment, some parts of this code, and then be able to execute our code. So the first thing that you do always when you are getting started with programming is print hello world. So let's say line number 8, 9, okay. Then line number 8 is a comment, just a section, tells us this is a section 1, and introduction to JavaScript programming, okay. So like what I've done is I've just written these two slashes, forward slashes, and then this, I said this is section 1, okay. And if I write the same thing like section 1 without forward slash, you see that now the colors are different, text color. So line number 8 here is a comment, and this one is not a comment. So if I run this, it's going to do something and it's going to give me an error, okay? And it's going to display in the console an error. Section is not defined. So we'll talk about defining variables, etc. In a short while. So when you, so what I want us to do is from section, so section number 1 for me here is line number 11. So we can just remove the double slashes, forward slashes, just remove them. And then you have print hello world. So print, okay. So I'll just try to rewrite this, okay. Print, then open bracket, close bracket, then single quotes, and I write hello world, exclamation mark. And at the end of this line, I've put semicolon. So if I click on run, okay, so if I had uncommented that, move the double slashes and click on run, now you see in the console, you should see hello world. For if you only have one print hello world, you only need to have one. I have 2 here, that's why I've having two items appearing in the console. So what I'm telling JavaScript is I want you to print, so I'm telling my computer, print hello world on the console, to the console. That's what is happening here, and that's what is being printed, hello world. So you know that a computer program is just instructions that you give your computer for it to do. So if I would say, okay, I don't want hello world, I want hello Africa. So a computer is going to obey. So it prints hello Africa. Okay. And okay, and this other one doesn't have to be hello world, it has to be hello Google Earth Engine. Okay, maybe welcome to Google Earth Engine for beginners. Now it prints hello Africa, then it also prints welcome to Google Earth Engine for beginners. So started writing something and I'm getting somewhere. Now, apart from telling a computer to print something, so JavaScript program, they are just like other computer programs or computer programming languages. They are also variable. So a variable is okay, an object that stores something. So you're saying that I want to store a value in something. So you can create a variable. So so I will remove the additional double slash. I just have um, 2 forward slashes and comment line 15 and comment line 16. Now, when you read what I have here, var country equals Zambia, and you see that I've used var lowercase, and I have country. I have used an equal sign. Then I've placed Zambia inside single quotes, and I've placed a semicolon at the end. So var or var is a keyword that is used to declare a variable. So to tell to store a value here is Zambia in country. So whenever I'm accessing country, I'm accessing Zambia. Okay. So when I say print country, I'm saying that I want to print a value that is stored in a variable Zambia, in a variable country, and that value that we expect to be printed on the console is Zambia. So another thing that to note is at the end of each line, I'm putting a semicolon just to declare that this is the end of this statement. So without a semicolon, it's still going to work, but it's a good practice to put a semicolon at the end of a statement. So this is a statement. And this is a statement. So this is a comment. So no need for me to put a semicolon. It's a comment, just indicating that these are variables. So if I run the script, now I have hello Africa. So what I have from 11 and 12, welcome to Google Earth Engine for beginners, and also I have Zambia printed. So print country, but now what is printed is not country. What's being printed here is Zambia, because Zambia is stored in country. So we know how to print something. Now we know about variables. The next thing that you need, okay, maybe we have printed this variable, which is which is inside single quote. It can also be inside double quotes. It's also going to work. Okay, run, still might print out Zambia. And
sorry, Dickson, to cut you.
Yes.
Yes, but we're having a challenge this side. Our line for run, save, and get rank, they're not active, so we're failing to run the command. Could you assist, please?
All right. Sorry for that. The first thing that I've skipped something that I was supposed to tell you. So what you're supposed to do is I've shared that code that link as mine a link to this code. But what you need to do is you need to save it as your own. Sorry, thank you for that. And please always, if you meet any problem, always unmute and let me know. So what you're just supposed to do is just edit anyway. So you can just put in a space anywhere, click anywhere, and then put and use your space bar, or you can uncomment like what I've done here. So after uncommenting, you'll see that the name of your script may not be this one because you are accessing it through a URL. It has a star, an asterisk, indicating that it's not something. It's not saved. So this script is not saved. So what you need to do, if after uncommenting, let's say line number 11 for me here, line number 12, removing the forward slashes, you should have this save active. Okay. Now you need to save this now as your own. So you click on save or save as. So the drop down arrow, then save as. Okay. So if you're clicking as save as, because it's the first time for you to work in Earth Engine, and if this is your first script, maybe you'll be prompted to write or a repository name. So just write anything, okay? Anything that you would want to be a repository name, okay? Maybe webinars or anything. So for me, I have webinars. So I have webinars. So you can write webinars. Then when you are asked to write, then you can indicate the name of the script. So the name for me is Google Earth Engine for G for beginners. So I'm putting underscores to make sure that I don't have space in the name of the script. It's good practice. You can name it whatsoever you want. Okay. And then you can forgo the .js at the end. It's still not going to work. Okay. And then hit OK. Then that script should be saved. So I'll just give 2 minutes for people to do that, and then see what's going to happen. So when you save that, okay, when you save that, it's going to appear under your under script. So scripts, and then scripts that are owned by your owner. Owner shows that the scripts that you own. So then there's writer. Okay, scripts that are that are accessible for you as to contribute. Then reader, scripts that you can only access. You cannot write anything. Okay, so it's going to appear under owner. Then based on the repository that you had indicated. For me, then I have users, Dickson Mbeya. So this is my username, just captured from my email address. My email address is dickmbeya@gmail.com. So when I was registering, I indicated this, and this is what is appearing here. And then I have a repository, webinars. Okay, and that's under that. In the webinars, I created a folder, G for beginners. So you don't need to create a folder. You can create one, but you don't need a folder. Then my script was saved with this name, and it's appearing in this because I specified that it has to be saved in this repository webinars. So I have my script. So that's what you need to do. When that is done, you can start to do an analysis. So when you click run, then you should be able to, the script should be able to be giving an output appearing in the console. Later on, outputs will be appearing on the map. Let me just check in case someone is still having problems. Okay. Okay. Let me just get a confirmation that we are all good now. Okay, so Ruth, if you can just do what I've said. First thing is you need to change anything. So your script has to be edited for you to be able to save it. So how do you edit it? Just remove. So you had, let's say, forward slashes in the original script for line number. Say for me, here's line number 11. Print. Then there was hello world. So all you just need to do is remove the forward slashes, and then your script is going to show that it has been edited. Or you can just click anywhere in anywhere and then add space. So space bar, add space, and then you go on save. Okay, save as. Okay, and give it a name, any name that you would want to give it. So if the first time for you to use Google Earth Engine, you need to indicate the repository, for instance, and then you need to specify the name of the script and hit OK. And that should work without any issues. Okay, so I have a copy of my script now. So you see now I have this one saved as a copy, second one. Is that done now? Just checking to make sure that we are all on the same page. Ruth, is it working now? Or anyone who has been successful, just thumbs up. Great, Philip. Okay, all right. That's great. And we continue. All right, so when that is done, I should be able to do what I was demonstrating here. Okay. So I was saying that we had Zambia, for instance, here. We can create a different variable, and now we want to store a value which is a number. So like that's what this line is doing. I can just remove the comments, and then it's var population equals 21 million. So Zambia has 21 million plus people, and I want now to create a variable for population, the var population, then 21 million. And I want to print this, then I just need to type print population. So print, then open bracket population, close bracket, then I indicate that this is the end of my statement with a semicolon. And if I run this, now I have another item being printed, which is the population itself, 21 million. Okay. So we can move on to the next item, which is list. So a list, a list allows us to store multiple values in a variable. So remember here we're only storing, let's say, one value, Zambia, or one value, our population. But if we want to store a number of values in a variable, we could use a list. And the way you write a list is you use the square brackets. So the square brackets. So what I've done, what this line 23 is doing is first is saying I want to create a variable, and the name should be countries. So this variable is going to store countries names. And then I want this has to be and this has to be a list. So what I'll do is I'll indicate that this is going to be a list using a square bracket. So hit square bracket, then Zambia. Then I'm saying, okay, another country is Zimbabwe. So maybe neighboring countries, Zambia. Then Malawi and Tanzania. So these are neighboring countries of Tanzania. Yeah. So okay, countries spelling. So countries, and then I'm storing more than one variable, one value in a variable countries. That's what I'm doing here. If I run this now, why are you not running now? Okay, let me save this. Okay, fine. So if I run, you see nothing is showing here. So it's working, but it's not showing because line number 24 is still commented. So print countries. So I cannot print anything to the console without writing print. So if I take out the comments, if I take away the comments, and you'll be able to see now that if I run, now I have a list printed. So I'm printing countries. If I expand this arrow, you'll see that I'll see now all the values that are kept in that list. 0, 1, 2, 3. These are indices. An index just a position of a value. So Zambia is position 0, 1, 2, 3. So an index starts with 0 in a list. So if I wanted to access Zambia, then I'll use an index 0. So this is I have stored more than one variables more than one values in a single variable. The next thing is objects. So objects in Earth Engine allow you to, or in JavaScript, not anything, but in JavaScript, because now we're just talking about JavaScript. Objects in JavaScript allow you to store key value pairs, where each key can be referred to, or each value can be referred to as by its key. So we're going to see an example. So I'll now show you how you can remove comments from a number of lines using a keyboard shortcut. So I'll just, let's say, highlight from line number 28 for me to line number anything up to line number 33, like what I've done. So I want to remove comments from this chunk of code. So what I would do, highlight that and then hit Control. Okay, Control, keyboard shortcut Control and /. Okay, so Control and / on Windows. Then that uncomments more than one, or that uncomments a statement. So I've removed the comment from this block, code block. So I'm creating what is known as a dictionary, and I am creating a dictionary is going to have key and values, and I'm creating a dictionary named Zambia info, and I would want to have some information about Zambia and number of people in terms of male and female, but also the cities, some of the cities in Zambia. So I have, for instance, male population and the value, female population, the value, and cities, and the names of the cities. You see the chart. Okay. All right. Now, what is happening here is I'm creating. So I'll just rewrite what I have here. So I'm creating a dictionary for me to be able to store key and values. So male population is a key and the value is 10,200,000. So female population, so number of females in Zambia, you have 10,400,000. And we pick some cities within Zambia. So we have, so this is now a list. So Lusaka, Kitwe, and Shingola. So, and end my statement. So the name of this dictionary is Zambia info. So this is the name. This is a variable. Create a variable named Zambia info, but this variable is a dictionary that has keys and values. So male population, female population, cities, these are values. So you can have a value as a number, you can have a value as a list, or you can have a value as a text. So a text or string, or text is also known as string. So I would have something different, like, so I would have, let's say, president, and I would indicate, so we only have one president at a time, HH. So the president of Zambia is Hakainde Hichilema, so abbreviated HH here. And if I run this, you see now I have 3 objects. Okay, so if I expand this, I have cities, and then this is a list. So cities, Lusaka, Kitwe, and Shingola, and the female population, a value, male population. Okay, so this is what I have here, line number 28 to line number 33 does that. But I need also to print again this, so I can print again, repeat the same thing after I did before. Zambia info, just to make sure that I get these updates. So this one has 4 properties: cities, female population, male population, and president. So I have all those values. So I have keys and values, keys and values. This is a dictionary. The final thing that you need to learn, the final JavaScript that you need to know for you to work with Earth Engine without problems, is what are known as functions. So if something is not working, as I said, feel free to unmute, and then you can speak out, and then we can get that sorted as we move on. The final thing that you need to know about JavaScript is what are known as functions. So what is a function? So functions is just a collection of code where you write in order to take user inputs or to allow you to group a set of operations. So you are like you grouping a set of operations together, and that you want to those operations to be repeated, but without the need for you to rewrite again the full chunk of code that you had written before. So you just use the function to perform the same operations. So an example that we have, let's say you can comment 45, line 45 to line number 49. I'm creating a function named sum, and I want to add two numbers. I want to add, this function should be able to add two numbers. Okay. So to create a function in JavaScript, you use the function you use function keys, function. So like this function. So you're creating a function, okay? And you can specify what are the parameters, okay? What is going to be an input in that function. And what I'm writing here, I'm creating a function that adds two numbers. So var sum. So the name of this function is sum. Okay. Then the function is having two parameters A and B. So A and B are standing for any numbers two numbers that I would want to add. Okay. A, B, then curly bracket, then return A plus B. So what I want to happen is after I get an input of these two numbers, I want this function to add the numbers. So it's adding A and B. And then I'm closing by a curly bracket and then a semicolon. So that's what is happening here. So after this function, that's why we have print sum1. So it's just the same as print. So I want to sum, so 1 and 1. Okay. But this, I want this to be printed. So that's why we're saying, okay, print. So this has to be printed on the console print. Then this sum should be inside the print. So sum 1, 1. Okay. So if I run, I get, so sum 1 plus 1 is 2. And then the repetition 1 plus 1 is 2. And 5 plus 5 is 10. I can also say print sum 2 and 3. I need to get a 5. Yeah, so I have a 5 also printed here. So instead of me writing again this, now and then I should be writing this. I'm just using some function. So and then indicating, changing the numbers, and I'm getting the output. So in application, you would have multiple operations that would want to be done, and you don't want to be repeating the same thing. So just need to write a function and then have everything enclosed in the function. So you only call the function and you're able to run the operation. So that is, so what I will do now is I'll print and say, congratulations, you are now a JavaScript programmer. Yeah, that's who you are. You are now a JavaScript programmer, and you can now start writing code in JavaScript, in Google Earth Engine JavaScript API for you to work with remote sensing images or any other data set. That's the whole. That's all the JavaScript programming that you need to learn for you to be able to work in Earth Engine. You check anything in the chat. No, I hope everything is okay. We can move to the real stuff. Now, what we do is what we do now is okay, before we move to bring this guy back. So before we move to getting images, the other thing that I will talk about is Earth Engine objects. So Earth Engine objects, these So Earth Engine objects allow you to access the methods already developed in Earth Engine. And if you click on Docs tab, you see what you have here. EE. So they start with EE, Earth Engine, then .algorithms, Earth Engine .arrays, EE matrix, etc. For instance, we had written a function that was adding numbers. You can access an Earth Engine object known as EE dot number. So EE dot number. EE dot number. Okay. Let me minimize this, remove this EE stuff. So this is EE number. So EE number, and you have EE number, and then you have one of the methods here is add. This one, add. So instead of me writing a function, I can just use this available method already. And so if you go section number 2 and comment this block of code. So what I'm doing, I'm declaring a variable a equals 1, and I'm creating declaring a variable b equals 5. So I'm storing a value 1 in a value 5 in b. Then I'm saying creating another variable which I'm calling an answer, or can be a result answer, equals ee dot number a dot add b. So this is adding the two numbers. So just like before we created a function that was summing two numbers. So I can just use available methods in Earth Engine to do the same thing. And then here I'm just printing the answer. So where have I found this? So this is found here. So docs, and then we'll be able to say list of methods available. And that's what we're accessing here at. If If you click on it, double click, you see a description. Add the first value to the second, and then it said this left hand, the right is number, the right hand value. So we have E dot number A is the first number, plus dot add B is the right hand value, and you get an answer. Should be 4, should be 6. If we run this, we should have a 6 somewhere printed. Okay, you have a 6 there. Okay, any questions so far? Maybe pause for 2 minutes and see if we have any questions. Okay, so there are no questions. I hope everything is okay. So far so good. Great. Okay, let's proceed. So then we now start working with images. So the first thing that we are doing is we want to start to set our study area. And remember, so our study area for this session is Lusaka, which is a city found in Zambia, which is a country located in the southern Africa. So Zambia is located in southern Africa, and Lusaka is our study area. So now, how do somebody was asking, how do you determine the region of interest? Do you always have to import it, or you have to do what? So I say that there are 2 ways. The first thing is you can search whether you have data set in Earth Engine catalog, which you can just access it and just filter. I'll talk about filtering later. You can just filter, and then you the study area from the available data set, or you can import as an asset. So if I had a shapefile that maybe a polygon for the boundary of Lusaka, what I would just do is I would add that as an asset. So asset new, then upload as a shapefile, and then there's a list of an indication of what the data type or the files that support the shapefile that needs to be available. So I can hit on that and then select those files and upload. Okay, but in this case, what we're doing is we are not uploading anything. We are using what is available in Earth Engine. So in Earth Engine, there is a feature collection provided by FAO and GAOLU, simplified, that's the name, 500 meter resolution 2015 level 2 data set. So you have level 0 and you have level 1. Okay, so in terms of administration, so international boundary, country boundary, and then you have maybe regional boundaries. You have so level 2, and from this you'll be able to get the boundaries for a boundary for Lusaka. You can if you are looking for a separate location, you can also explore. I provided that is at level 2 in terms of administrative boundaries. So we can uncomment line number 70 and 71, and then for me it's 70 and 71. For you, it might be a different line because I have changed my code, and uncomment line number 75 for me, and I also uncomment lines 80 to 82. Okay, so your script should look like the way it is appearing for me there. I am so I will explain what is happening. I am declaring a variable, so that's why we had to start with variables. a variable admin2, and I'm saying that this is a feature collection. So a feature collection is a shapefile. So a shapefile, a collection of points, lines, or polygons. A feature collection. So I'm using what is already available in Earth Engine. So ee dot feature collection. So ee dot feature collection, and I'm saying that the ID. So this is an ID to that feature collection. This one, this whole line, and that is placed inside 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 single quotes. Okay, and place it there. FAO what. So you need to know the ID of the data set that you are fetching. Then I say, okay, and this one, then I'm creating another variable, which is my study area, from this data set, admin to filtering. So I'm filtering from source, just like if you worked with QGIS, ArcGIS, or any desktop GIS, it's just like you are selecting something from somewhere. So selecting admin1 should equal to, so filter e.filter.eq. So admin one name should be Lusaka. So like what we're having here is like admin one name equals Lusaka. Okay. So in desktop GIS, you would have an SQL command, and you would write an expression, something similar to that. Okay. So for us to do that in Earth Engine, we are filtering. So dot filter. And you can access this you can check what we have there in Earth Engine when you go to the documentation. Filter, here you have filter, and what does filter do? Constructs a new filter, okay, and it accepts these, okay, and filter. Then you have filter eq. What does that do? Is this one. It's filter to metadata equal to the given value, returns the constructed filter. So arguments can be the property name to the filter on, and a value to compare against. So so equal to, that's what we are having here, equal to admin name, then should be Lusaka. And then the other thing that we are doing is let me talk about what are known as image collection. So in Earth Engine, you have, if you go back to the data catalog, you'll see that we have a number of data sets. So if I go on Sentinel, then you have Sentinel collections. Okay. So you can access image collections in Earth Engine, and you can access them using IDs. So let's say Sentinel-2. So let's say in our example, in this session, we are looking at a Sentinel-2 dataset. So on Sentinel-2 collections, I would go to Sentinel-2 here. So Sentinel-2. And under Sentinel-2, you have also dataset of different processing levels. I'll go for surface reflectance because this one has been pre-processed. Okay, now I'm on harmonized Sentinel-2 MSI spectral instrument level 2A SR surface, which is standing for surface reflectance. So you have descriptions about the dataset availability from 2017, okay, to present, and then you have the ID here, and you have description of this dataset, what this dataset is, okay. You can check the bands. So how many bands, what bands are there, okay? And you'll be able to check them here and check the properties for the images, okay? And the terms of use. And down there, you have an example of a code, JavaScript, okay? JavaScript code, okay? Or Python. So the same thing in JavaScript, this is what you would write to access this collection. Or as an example, you can also write something like this in a Python, and you get the data set that you are looking at as an example. So what we are going to do is, all right, okay. So what we're going to do is we will access this collection in SDG. So what you can do is when you copy this, okay, copying this code, this is the same thing that like what we have here. So we are saying that let's create a variable which is S2 standing for Sentinel2, and this is an image collection, and this is a path or the ID of that image collection. Copernicus and S2 harmonized. Copernicus S2 harmonized. This one. So just like this is the same thing, similar to what we have here. Image collection Copernicus S2 harmonized. So we're accessing that data set. And the second thing that we're doing is after accessing this data set, no, this is everything. So imagine you have a folder, and within that folder you have a number of images. So all images for anywhere in the world, for all the years and days, you have all those images in that folder. And that's what we're accessing that folder. So we have access here to that folder. So if you can have, we can have that, have that analogy in mind. So we are having that folder here. And within that folder, you have images for all the countries, wheresoever you have Sentinel-2 images acquired from. And then for all the years and the days, you have the images available in that folder. And we want to access only certain images that are for our study area, and that are for a particular period, which also have a certain percentage cloud coverage. Remember, when you are downloading images from geoportals, you specify the cloud coverage, specify the date, and you specify your region of interest. Okay, and that's what we're doing here. So lines number 80 to 82, the first line is we are saying, okay, we want to filter. So we can use the filter to filter based on date, based on the area, and also based on the metadata. So metadata here is, our metadata is cloud pixel percentage. So we're saying that we're accessing a filter, filter by cloud percentage, and should be 30%. And again, filter by date. So we want images acquired in the month of September 2024. So when you are using filter.date, you start the first thing argument should be the start date, and the second one is the end date, but the end date is not included. So from September 1 to September 30, for us to have an images of September 30, we need to indicate to put 30. This is supposed to be, okay, so this is, you can edit this. This is supposed to be 1st October. Okay, so it's supposed to be 1st October. So it means 1st October is not included. So it means you have 1st September to 30th September 2020. Okay. Then we are saying that, okay, we want only images that are within our study area. and our study area is, we have defined our study area here. And this is our study area, Lusaka here. And that's what we have in line number 82. So if we run this, it doesn't do anything. Okay, it does execute all this, but we don't see anything on the map. We just see things printed which were already written before when we were doing introduction to basic JavaScript. That's fine. We're going to display something on the map soon. Then one thing that we from remote sensing, you know that you have you can create different composites, color composite, force color composite. So we're creating two color composites. The first is a natural color, and that's what we are doing in line number 80, 85 to 89. Okay. The first thing is we create that, we are creating it using a visualization parameter. So you create, we are declaring a variable RGB, this is red, green, blue, and so this is just a name. You can give it another name, but you want the name also to be meaningful. So the minimum, maximum, these are important to indicate because of the values that are in the image. So minimum 0.0, maximum 3,000. The bands. So Sentinel, we go back to Sentinel 2. And when you go on description and bands, and you have band 1. B1 is description, this is aerosols. B2 is blue. B3 is green. And B4 is red. So if you want to create an RGB composite, it means we need to have a 4-3-2 combination because this is Sentinel 2. And that's why, so let me bring this close. That's why here we have bands we've indicated. So if you have, let me go back to what we did before. Remember, we created a dictionary before. And this is also a dictionary. That's why we are creating dictionaries. So this is a dictionary, and the name is RGBVs, and you have a key and a value, a key and a value, a key and a value. And this is a list, B4, B3, B2. And then you create this, you're indicating this is an RGB composite. And you can also create a force color composite, okay? So I want to comment this block of code, force color composite, B8, B4, B3, near infrared, red, and green. So B8, if I check this, is B8 is near infrared. Okay. Then, okay. So I will also want to comment. So let's print the image, a September image. So if we want our September image, this one, an image that is going to be of 30% cloud coverage and captured within that month and within our study area. So we're saying, can we print that? If we run, and then we have what is printed is an image collection. And when I expand that, I have all those, and I have 96 elements. Let me expand the features. I have 96 images within my study area, Lusaka, which qualify this condition, or which are of 30% or less cloud coverage, 96 of them. Okay. So they are not displayed on the map because I'm just printing them. I'm not adding them to the map. I just print, then I check, I have all those images, 96. Okay, I can expand the features, the bands, then I have, so see that for each element, for each image, and you have a band 1, band 10, up to the other metadata. bands, QA10, QA60, etc. And that is true for all the images. So that's what we have. So we have 96 images from this. Now, how do we display 96 images on the same map at once? So we need to create a composite. So, so what I would do is I will comment line number 102 for me. So you can create a composite image. So of all the images, you can say, okay, I want of 96 images, I just want median values from all the, create a single image, a composite image that has median values from the 96 images. So you can use the median function. So I'm creating a variable named as toComposite, and I'm placing that inside the I am accessing the previous output, which is September image. And this image, I'm saying that I apply to this image a median function. Okay, so get median values from this and create a single image. And that's what I'm doing in line number 102. If I can print, let's see what's going to happen. So I'm just trying to print. So if I try to print the composite, what is going to happen? We'll see together. So you see that we had, so this is for before creating a composite, we had 96 elements, which are different images. And now you only have one image. Okay. Now here type was image collection. Okay, because it's a list of all images that that are falling within this dead with this crowd coverage and falling within our study area. But now then we say, okay, we just want create a composite image from all those and based on the median value. And you create a single image type. Now it's just an image, a single image with 19 elements, which are the bands. So a list of the bands. So what it means here is we have successfully created a composite image. Then you would say, okay, if I would say, so now I'll add this composite, I'll do this map. So I'm introducing something new, map, add layer. So what does map.addLayer do? So a map.addLayer adds a given Earth engine object to the map as a layer, and it returns a new map layer. So that's what's going to happen. So we would want to add this object S2 composite to the map. So I will indicate here the object itself S2 composite. Then I'll specify the visualization parameters that were created. I want an RGB. So we created a dictionary for RGB composite, RGBVs. That's what I'm adding here. And a map.addLayer also takes in, I can specify the name of my layer. Okay. Osaka composite. At least we need to have something in the map. So Usaga composite and I hit run, see if we're going to have anything on the map. Yeah, so we can see images. Can see an image. So one thing for you, if your map is still centered to USA, just scroll down and comment like the final line, center map to to geometry or center map to study area. Just uncomment the final line in the code. Map.center object study area. And then your map should center to Lusaka when you run. So you run the script and your map should center to Lusaka. Let me see if we still, okay. Okay, someone is getting 151 elements. Okay. I'll see. Confirm if maybe there was something that has changed. Okay. But when you look at this map, is not falling with it's not just confined to the boundary of Osaka, but it goes beyond the boundary. So all that we need to do is we need to clip this to the study area. Our study area is Osaka, and what we do, and we've stored that study area inside in a variable known as study area. So I'll uncomment my line number 108 var s2 composite dot clip study area. So what we're doing here is we are using the clip function to clip the study to clip this image, this output to the study area, the boundary of Lusaka, and that's what we're doing. And then we want to add this to the map. So if you want to add anything to the map.add layer. If you want to add a layer to the map, so this you use this. So the same thing, map.add layer. Okay, so you need to have an object. These parameters, visualization parameters. The name is the name that you give, like Lusaka. Then shown, you can, if you put 0, if I would add a 0 here, it means that this will not be shown on the map, but you can access it from the layers. So it's like you've unchecked it. Okay, and then opacity, you can indicate that. So it's still more, we still said this is S2 composite. And okay, we still want it as GBV. So what I'm writing here is the same thing. You can just uncomment this line of code. Okay. So okay, just uncomment this line of code, and you have something different. Let me see. Yeah. So now we have two separate layers because I added another line of code which was not there before. So I can just uncheck the first one. So you see now I have the image is clipped to the study area. Okay, then you would say, okay, I have the RGB. Let me also have the force color composite. So that's why we are writing this, adding a force color composite. So you're just changing the visualization parameters by indicating the dictionaries that were already created here, defined here as a visualization parameters. Okay, applying to the same object, the same image that we've clipped. And if you run that, okay. Now you have a force color composite where vegetation appears red. I can, if you, so you go on layers, you can uncheck or check it, activate it or switch it off. So I switch on the force color composite, and you see the names that are appearing here. These are layer names as layer names. These are the same names what I defined here. So what I've defined here is what I'm seeing here. So the beauty about Earth Engine is if I wanted to do it for a different country, all that I would do is I will just change the name here. Wait, the study area. Okay. Yeah. So let me change this. If I just change this to, let me see what's going the wrong way. Okay. If it says no, it means it's that 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 one is not available in there. Harare. Yeah. So I changed to Zimbabwe, for instance, Harare, and I just changed the study area, and the other part of code is the same. Okay. Just change the study area, and I can perform my analysis for a different study area. No need for me to rewrite the entire code. Okay. But if it's about the traditional way of doing things, then I needed to go on USGSF Explorer, for instance, download images for my study area, Harare, and then open the images in uh, QGIS, ArcMap, ArcGIS, and then clip, mask by extent or by layer, etc. Do all those things. But that's what is happening just by changing the name here, and then I'm getting images, clipping, etc. for a separate area, creating composite for a totally different area. No need for me to download anything. Just checking the chat because someone is posted something. Okay, I hope everything is okay. Okay, so and we'll see that now I am in a different place, and I can analyze my data set. So it's Sentinel-2 data for a different country, different region. So Harare, for instance. You can change this to, let's try to move out of Africa. We pray that it works. London. I change this to London and see what's going to happen. Okay, if it gives an error, it shows that it means that that one is not available. So if it gives an error, it gives you a line where you have a problem. Line number 148 cannot read properties undefined, etc. And it gives me this is line number 48. And study area, it means that my study area has problems. So that name maybe it's not available in the data. Final one, Cairo. Yeah. So Egypt. And you see, now I've gone somewhere different. Okay, so you do this and you don't need to download the data and things are just working. No need for you to download data. So let me bring back our study area and rerun my code. So I'll comment out the uncrypt layer. Okay. This one. So let me uncomment this one. I don't need that. So this is how you can work with a feature, an image collection. So from images that are available, you can filter from those images by date. So you can specify different dates. If I wanted a different year, okay. If my analysis was for a different year, all that I need to do is change the year here. If I want to do an analysis for 2020, I just need to put a 0 and remove a 4 and put a 0, remove a 4, and I'll have images for 2020 for September, the month of September. If I need a different month, I just need to change a month, okay, and change the month, and then I get images for a different year, different month. So no need for me to download, etc. So as Google says, they want scientists to focus on science and not downloading data. Okay, let's finalize by looking at spectral indices, and we'll just look at one of the common spectral index, normalized difference vegetation index. So a normalized difference vegetation index allows you to monitor vegetation, and you can perform a time series analysis and evaluate the condition of vegetation or degradation of vegetation. You can use NDVI to monitor crop health, monitor vegetation. Also, you can use NDVI for drought assessment because vegetation responds to rainfall. So the amount of rainfall that an area receives determines the health or the kind of vegetation that you'll be able to see. And if there's erratic rainfall, if there's drought, you expect that vegetation also is going to be affected. So you can use the NDVI, the normalized difference vegetation index, to assess vegetation health. So a normalized difference vegetation index is calculated using the formula NDVI equals near infrared minus red divided by near infrared plus red. And this index, what you are dividing here, they are bands, the image bands. It's seen before that we had 19 bands, and from these bands you access the near infrared, which is band number 8, and the minus red, which is band number 4. So which is B8 minus B4 divided by B8 plus B4. And you create a new image which is going to have values ranging between 1 and -1. So -1 and 1. So those values will indicate the status of vegetation. So values closer to 1, vegetation is in good health, and values closer to 0, vegetation is not in good health, or it's bare land. Okay, below 0, mostly it's water or snow or clouds. So we'll demonstrate with one index. Okay, so okay, maybe you can just search NDVI. Okay, so the normalized difference vegetation index. Let's check here. So if someone is not familiar with NDVI, okay, so so it's used to quantify vegetation greenness, useful in assessing vegetation density, changes in plant health, etc., and the formula that I was talking about. So what you need to do, you need to understand is to understand that the kind of image that I'm working with, okay? If I'm working with Sentinel data, what are the band designations? What's band, which band, image band is near infrared, which image band is red, for instance. So if I'm working with Landsat 7, which image band is near infrared, which image band is red? So that's very important, okay? And based on the values that you get, you can determine vegetation greenness, okay, vegetation density, and plant health. The reason is when satellites sensors are capturing images, they're using energy that is reflected. So when energy that is reflected from different objects, the energy that is reflected by different objects, the reflection is different. So vegetation that is green and vegetation that is dry is going to give different reflectance patterns of energy. So when the sun hits the surface, that sun energy is it's known as electromagnetic radiation. Is reflected, and different features reflect a certain portion or percentage of energy, and that is used that difference is used to identify different features on the Earth's surface. So green vegetation reflects more um, uh, the more reflectance in the near infrared portion of that energy that is incident on the green leaf because of the plant cells or leaf cells, and then the other portion of the energy, red portion is a great portion of it is absorbed by the pigments in the leaf. So we expect that there's going to be high reflectance in the near infrared and lower reflectance in the red portion of the energy that is incident on green vegetation. So that difference can help us to come up with an index like NDVI, and the values that you get would inform us in terms of the amount of reflectance. So like when you have a bigger value in the near infrared, which means high reflectance, and lower value in the red, you expect that you have when you are subtracting a smaller value from a bigger value, and you are dividing, and then you're getting a bigger value. When you are subtracting, when there is more absorption, it means more absorption of near infrared, it means that that vegetation is not in good health, and high reflectance in the red portion, it means not in good health, and you have a bigger number inside, a lower number, and you're getting a negative or lower values. So that shows, and it means you are dividing also by the bigger number this side, lower number this side, and then you're getting values closer to that are not close to one, and you indicating that vegetation is not maybe it's not green or not in good health, plant is not good health. So we'll try to demonstrate that just to calculate NDVI in Earth Engine. So we can uncomment. So uncomment line number 120 to 128, where it says spectral indices, var, NDVI, etc. And so this line 121 and 122 remain commented just for you to understand. So how do you calculate NDVI? So to calculate an index, use the normalized difference function. So normalized difference function. So you can check even this side to say, what does this function do? Normalized. So normalized difference function computes the normalized difference between two bands. If the bands to use are not specified, use the first two bands. Okay. And then this is how computation works. First minus second divided by first plus second. Okay. And this is what we are doing here. And we are using normalized difference. And we are saying that, okay, the bands that we are using, band number 8 and band number 4. So first minus second divided by first plus second. That's what we are doing here. And we are saying that, okay, the output that we're going to get, which is an NDVI, okay, should be kept in a variable NDVI. And we are applying this function. We are calculating this from what we had before, the composite that we had created. Okay, and then we're saying that the output, which is an image that's going to get, it's going to be a new image or a band, and should be named NDVI. That's why I'm renaming it NDVI here. That's what the rename function is doing here. So these are comments just to indicate the formula for calculating NDVI and the function used. Then we say, okay, let's print the no band number of bands. It's not supposed to be Malawi. So it's not supposed to be Malawi. This is supposed to be S2 composite. So you can edit this to be S2 composite. So number of bands before we adding this NDVI output, you just want to know. And then you can run that and you get the output. Number of bands before adding 19. Then after adding, so we line number 127, we're saying that what we have calculated here, this band should be added to the composite. So the same image should have another band, but that band should be NDVI. And that's what we're doing, add band. So we're using add band function. And we're indicating what are we adding? We're adding NDVI, which is this output that's coming from this operation. And when we print, we say, okay, how many bands now do we have? Because we have kept this again in the same variable. Now we have 120. Now we have 20 bands. So the 20th one is NDVI, and we can explore this and check that we have the final one is band. So it is 18, but it's 19 because we are starting to count from 0. Okay, and now, but for this one, we have now 19, and this one is now NDVI. And you have to see the range of values, -1 and 1. Okay, we know if we are winning. Okay. So how can we identify vegetation from crop during analyzing? Okay, we'll see. We'll get to that. Okay, so then okay, just want to remove this. So if I want to present this on the map, the NDVI, I have also to set the visualization parameters. How do I want it to be visualized? If we are working in a desktop computer, QGIS, ArcGIS, Pro, ArcMap, Supermap, iDesktop X, etc., you would specify the colors. You choose a color palette and then specify the colors, etc. But in Earth Engine, you can specify the visualization parameters. And that's what we are doing from number 132 to and comment 132 to 134. So we're saying that let us create a variable named NDVI visualization. Oh, this could be easy also be put in like this. So it's recommended in JavaScript to write variables in camel case. So like camel case would be NDVI, then this. So I'm saying NDVI visualization in terms of, instead of having a lowercase v here, I'll put this. So some people would be like NDVI this. as a name of a variable. So var and derive is. So this one is recommended, not this one, the way I had put it before. But you can leave it as it is so that it's for you not to get an error. I'll change mine. I also change down here. So var and derive is, then I'm specifying the minimum should be 0 and the maximum should be 0.5. This is not the minimum and derive value, but this is the minimum of what's going to be visualized on the map. So on the map, anything 0 and below is going to have the same color. Anything 0.5 and above is going to have the same color. That's what I'm indicating. And the colors, the ranges that I have between 0 and 0.5, I have these different colors. So this is the color palette. I have these different colors. These are X color codes. So they symbolize, they stand for different colors that you so have all these colors specified. And if you look at this carefully, you see that this is a dictionary. So this is a variable and this is a dictionary. A value, okay, a key and a value, a key and a value, a key and a value, which is a list, a key and a value, which is a list of colors. That's a dictionary. That's why we learned about dictionaries. And then I can display this on the map. So if I want to add to on the map, I need to use map.add layer and then specify the object that I'm adding, the visualization parameters, and the name, and then make it checked or not. So if I 0 means that I want it to be off, switched off. So because I changed this, I'm going to change that and run. Okay, now you see that the end divide map is not showing. The reason is I had put a 0 here. So when it loads, it runs, and then in the layers, it comes switched off. So I can just switch it on by just checking it. Now I have an NDVI map. Okay, I can uncheck these other guys. So this is an NDVI map for Lusaka. So areas where it's green, dark green, it means there is dark green vegetation that side. 0.5, NDVI 0.5 and above. Brown areas, low NDVI values. Let's say here this should be an irrigated, should be showing irrigation, a farm here. And we can confirm this by bringing back the color infrared or force color, and then you can use this to slider to make a layer transparent or opaque or transparent. So you see that the areas where I have bright red, that's where I'm also having green colors, deep green colors for my NDVI map. And that is coinciding with areas where I have green vegetation. Because in a force color composite, green vegetation is going to be bright red or deep red. Okay. We can further confirm this by I wanted to bring back the terrain. The satellite image. Yeah, and you see that this area, yeah. So that's okay. So this is green vegetation, and you see on a natural color for a true color composite RGB, and you see that that's why you have uh, deep green colors. So yeah, so I think we have covered pretty much. So this should be build up area. Yeah, you see this is a built up area, and and you see that NDVI values there are very low. So except where you have vegetation, trees, etc. Yeah, so reaching this far, we've covered almost everything that we planned to look at in introduction to Earth Engine, and we looked at introduction to JavaScript API, looked at Earth Engine, what it is, what it's able to do, what you can do with it, but also basics of JavaScript programming, now how you can work with images, how you can calculate spectral indices and visualize. Or the only thing that we're not doing is exporting images. So exporting this for you to work with it in a software, a ArcGIS software, QGIS software, etc. All right. Let me now get questions, comments. Let me first go to the chat and so since both vegetation crop or vegetation and crop shows green reflectance, how can we identify vegetation from crop during analyzing NDVI? Okay, so NDVI is just an indicator. It's just an indicator, and you don't need to 100% rely on NDVI for your analysis because it shows just greenness. So it's about greenness, plant health. So whether it's vegetation, trees, a green tree or a green maize field, a green rice field, it's going to show similar values. So you need to apply further other parameters for you to, if you want to identify specific vegetation, etc., and perform more analysis for you to be able to use it to distinguish between different kinds of vegetation. But it can, if you know the location of maize fields or you know the location of crop fields, then you can use that in your assessment. So you already know where you have maize fields, or you have rice fields, or you have whatsoever crop you are growing, and you can use NDVI to assess the condition of that uh, of crops that you've grown in that field, even maturity, maybe the health of the crops, etc. How do we add a legend from here? Wow, we're not going to cover that. Adding a legend, there is a process of doing that. It's not as straightforward as it is in when you're working in with QGIS or ArcGIS, etc. So yeah, yeah. So I think that's it. So what I'll do is I'll share the recording just for you to go through uh, this again at your own time during your own free time. But I also I think add a component that we've not covered. Export, how you can export an image from this. Somebody also has indicated how you can add a legend. So maybe those two components I'll add them to the script and then share the link with everyone that registered. that they can work with it. I hope you found this session useful. Okay, let me now switch on my camera. I'm not sure if you are able to see me. Yeah, anything. 2 minutes. You can speak out now.
Hi, Dickson.
Hi.
I have a question.
Mm-hmm.
If I want a time series analysis,
Mm-hmm.
do I have to set up the dates individually or just once at a go?
Yeah, okay. So if you would want to perform a time series analysis, and okay, it depends on what analysis you're interested in performing. But you define the time period. Okay, let me say this. Let me go back to where we have the dates. Yeah. So if you're assessing, for instance, we want to assess the changes in NDVI for 10 years. Yeah, so something like that, 10 years. It means you need to find the dates. You define the dates, and so there are a lot of things that you can do, which we have not explored here. You can generate plots, charts, let's say for you to look at the changes in terms of NDVI for a particular area for the past 10 years, and be able to identify areas where you have, let's say an NDVI anomaly, where you have a deviation from long-term mean of NDVI, and that can show you whether an area is maybe experienced a drought, for instance. So that's how NDVI is applied for drought analysis, for you to be able to um, look at the trends in the terms of changes. So you need to specify the dates. You need to specify the time period and make a few changes to make sure that based on the objective of the analysis, you are able to achieve what you want. So it means if you're looking at a 10-year period, you need to specify that, and you can also specify the season. So depending on season, for instance, an example of NDVI, depending on seasonality. So NDVI is seasonal. It's going to show you changes based on the season. So during the dry season, you expect that in some areas you have uh, low values because it's dry season. But during the rainy season, you have green vegetation or shrubs or grassland, and then you have high values. So even the trend will be seasonal. So it means sometimes you specify the seasons, you specify the years and also the seasons, and make those kinds of analysis. So there are a lot of things that you do beyond what we've covered here. Even let's say you are monitoring forest degradation, you can perform that analysis over a period of 10 years, 20 years. There are also algorithms that people have developed and which you can just import them into a code and have them be able to use them. Yeah, so I hope I have indirectly responded to that question. Thank you so much. As I indicated, I'll share this and share the code also so that you can work on, apply it and see where to start from. And yeah, and maybe in the next sessions that I may come up with, I'll be able to see what else to cover. So maybe after this, I'll share a survey, and then you can indicate areas of interest. What you want to know now that you've gotten some understanding of what a Google Earth Engine is, what you can do, what are you interested in, that you would think that maybe if I would get to know how to do this, I think that would work for me. So I know we have a lot of area fields in which we're working in our desired applications. Yeah. Otherwise, all the best and good luck with Google Earth Engine. Bye.
Thank you so much. Thank you so much. Bye bye.
Bye bye.